Welcome to another episode of How to Do Maths. Today we're going to look at problems which seem to be quotient rule problems but in fact are not quotient rule problems, and I've done a few examples here to show you. When we just have some quadratic function or some function that's only got powers of x and we've got an x on the denominator, then we can actually do the division quite simply by making this three separate terms. We do the division, we get that. And instead of using this, differentiating this by the quotient rule, differentiating this is very simple, and we have the answer down here. Remember, as I said, write down these powers and you won't make a mistake. That's very important to remember and to do it every time. I've seen many students when they've started at master coaching have solved problems like this by first writing it like this and a number of other difficult ways of trying to solve the problem. It's very simple. The power is -2. Power times coefficient. We notice the 2's cancel out, so we get -5/2. We take 1 from the power. We get -3, which is 3 on the denominator. And the same with ones like this. We've done functions of functions. Then we have, all right, the power of this bracket is -1. -1 times 7 gives us -7. The differential of the bracket goes on top of the fraction, and the power of the bracket on the bottom of the fraction becomes squared. That can be sort of exemplified when we just have not just one term down here, we have to the power of 3. We do it in exactly the same way. So we have -3 times 8 gives us -24. The differential of the bracket goes on top, and the power, we take 1 from the power, so we take the power goes to -4, which means it's 4 on the denominator. Now, all of these are non-quotient rule problems. And when we get something like this, you have to recognise it is a quotient rule problem. But one I've often seen asked in the HSC, where they ask students to differentiate something like y equals x minus 1 over x plus 1 to get the second derivative. You can do this division, and you can rewrite this as equal to 1 minus 2 over x plus 1. So then the second derivative is very easy. The first derivative, y dash, equals +2 over x plus 1 squared. And the second derivative is equal to -4 over x plus 1 to the power of 3. So recognising when you need to use the quotient rule and when you don't need to is very important. When you're doing maths, it saves time in examinations.